IF communications, the kind of this model, IF communications. Okay, what is IF? What is IF? Not radar frequency, okay? Not radar frequency. It's radio frequency, okay? Since we are talking about radio frequency, then you could ask, we have microwave. What is the difference of radio frequency, IF, and microwave? Okay. Also, some students could hear about terahertz, right? So have you heard about this name? Terahertz means frequency much higher than IF frequency. Okay? Terahertz. Okay, so let's look at the electromagnetic wave, the whole spectrum. So actually the whole spectrum can cover from very low frequency, from here, very low frequency. For instance, the audio signal, right? Audio signal, then the power lines frequency, right? DC signal is frequency is 0, right? Okay, then above DC is the AC signal, actually AC signal. Okay. Also, M radio. What is the typical frequency range of M radio? Okay. Now M radio is not that popular because of the quality. FM radio is more popular, right? What is the typical FM radio frequency? Typically around 100 megahertz, right? Okay, typically around 100 megahertz. Okay. Then here is FM radio, right? Okay. Then we also make microwave oven frequency. Okay, I leave open. What is the typical frequency for microwave oven? Okay, then I could ask more popular frequency for Wi-Fi. Typically we call 2.4 gigahertz, right? But the frequency will cover a frequency band from 2.4 typically to 2.48 or 2.5, right? Okay. Also, we have another upper band is 5 gigahertz. Okay. So nowadays we have dual band Wi-Fi. Okay. High upper band frequency can deliver high data rate, right? Okay. Then you can download it faster. Then for cellular phone, what the frequency band are being used? Do you have the idea? For cellular phone. What, for instance, what are the typical frequency band for cellular phone? Sorry?
Less than 1 gigahertz.
Less than 1 gigahertz. Okay. Any other answer? Yes, less than 1 gigahertz is one frequency band. Actually, for cellular phone, now several frequency bands are being used. Okay, 1.8 gigahertz. Now, just now you mentioned below 1 gigahertz, typically is 900 megahertz. Also, is a frequency band. Okay, the center frequency would be 900 megahertz. 1.8 gigahertz. Okay, then third generation 3G is around 2 gigahertz. Right? Okay. Then LTE. Okay, you have heard about LTE, right? Okay, LTE is around 700 megahertz. Okay, anyway, you can Google to get the exact frequency band. Okay, right? Then fourth generation 4G, also with 4G, then you can download much faster, right? I guess most of you have experience. Okay, so very recently I also traveled to China. At that time, I cannot access Wi-Fi. I have to rely on my mobile phone to set as a hotspot, right? Okay, initially it's 2G. Okay, very slow. I cannot tolerate. I have to upgrade to 4G. Then much faster. I have to do some office work overseas. Okay, so means with the revolution of this wireless communication, we this revolution bring us a lot of convenience, right? A lot of convenience. Okay. Initially 2G, when I download, actually, typically Wi-Fi after a certain time, right? Then we'll disconnect. So because of that, I spend a lot of time, okay, to maybe download, send an email, okay. So after upgrade for 4G, then quite easier, okay. So next generation, now in the research industry, people are talking about 5G, okay, fifth generation 5G. Also, 2 or 3 weeks ago, United States released the frequency band for 5G, okay. Actually, higher frequency band are being used, okay. Previously, I guess I will show you the spectrum, right? Quite occupied, okay? So nowadays, have to move on to upper frequency band, okay? Now let's look at upper frequency band. Just now we mentioned the frequency, right? This axis is for frequency. Actually, F frequency or wavelength. Later on we will show the relationship. Why we spend much time on this slide? Very important concept. After some time, student may get all the theories, but you can understand those basic fundamentals, right? Okay, those related to frequency, wavelength, okay? Then for radar, okay, typically what frequency band are being used? For those who are in the military or defense industry, may have some idea, right? Okay, who can give me the answer? What are the typical frequency band for radar? Okay?
2 to 18 gigahertz.
Okay, this is the one frequency band. Okay, any other frequency band for radar application?
933
933
megahertz.
very good. Typically for long distance radar. Okay, long distance radar. Long distance here, long distance circulation up to 1,000 kilometers. Typically high power is used for this kind of application. Any other frequency? Okay, we are not planning. Okay, so you can. So I guess some of you are driving the car, right? Okay. So now radar also are being used. Maybe high-end car, even typical car. Okay. In the future, also we have later driverless, autonomous car. We use quite a number of radar sensors for this application. Right? For later, but anyway, here I leave it open. The frequencies for radar. If you are interested, okay. Nowadays you can learn by yourself, right? Okay. Typically also we train students how to learn by yourself. Okay. Give some information to you, then you can finish by yourself. Right? Okay. Then for just now also we mentioned the terahertz. Actually, terahertz is this frequency, 10 to 20. Typically, we are talking about the gigahertz, right? Terahertz actually is this frequency band. Nowadays, some people mention above this frequency band to call the terahertz. Actually, terahertz also later on mention at the airport, your millimeter wave imaging now is used for security purpose. Okay, terahertz is the good choice for security application. Okay, also can be this frequency nowadays becomes very small. Can be used for can be used to detect skin cancer, right? Okay. For imaging. Okay. Anyway, high frequency light wave also is one kind of electromagnetic spectrum. Okay. I will not cover too much for those obvious high wave, X-ray, those for high resolution imaging. Okay. High resolution. Okay. Correspondingly, we have the wavelengths. Okay. Wavelengths. So this is the wavelength corresponding size of the wavelengths. Okay. For instance, at this gigahertz, the wavelength is similar to the baseball size, and this frequency may be corresponding to this soft field, the house size. High frequency, the wavelength is very small, comparable to a cell. Okay. The relationship. Another question we have not addressed is the difference of radio frequency and the microwave. Also, typically, so also we have the so-called high HF, right? Or not HF. The high. Sometimes we call the high frequency, right? Okay, HF. Anywhere here, we mention the radio frequency, high frequency. Typically, maybe below 3 GHz, we call the IF. But the boundary is not that clear. Okay, depends on the reference. Okay, for instance, by comparing the terahertz, maybe 60 GHz high frequency could be considered IF frequency. Typically, IF could be. You also can Google on the website what is the definition of radio frequency or microwave frequency. Typically, microwave frequency is called the frequency range from 3 GHz to 300 GHz. Because the microwave frequency below 3 GHz, maybe 300 MHz or 300 kHz. The low, also not that very clear. Okay. Now all this. Sometimes the definition is not that very clear. Anyway, compare with microwave frequency, typically high frequency is lower frequency. Anyway. Then the relationship between the frequency and the wavelength is equation. It's very straightforward. Very straightforward. Okay? It is by the speed of light in free space. Right? This is the 3 times 10 to 8. The speed of light in free space. Okay? Then you can find the relationship of the frequency and the wavelength. Okay? For instance, one big difference by using this equation, you can get this wavelength. Okay? High frequency means this sine wave much dense, right? Okay? Much dense. High frequency. Okay? Low frequency, much loose. Right? Okay? Then let's look at those very important applications. We will give some background of high communications. This the traditional application for military application for radar, right? This for Navy, for this aircraft, right? This is actually still so-called STLC aircraft. STLC aircraft. This actually the concept behind of this is when radar look at this object aircraft, the size becomes smaller, so-called the STLC. Okay, for instance, this is very very huge, right? With modern technology, maybe material scientists, how to invent those material to absorb the electromagnetic wave, EM waves. Also, the structure, also our EM people also are working on that to have minimum the size by looking at from the radar. Okay, is maybe the size from radar point of view, the size could be smaller, as small as a bird size, and so-called the STLC. Then the radar, this aircraft cannot be detected. That cannot be detected. Then you don't have enough time to react. Okay, so it's very important for military application. I guess defense has invest a lot, not only the United States, Singapore, okay, invest a lot. Also this multidisciplinary research work is still ongoing. Okay, ongoing. This aircraft maybe also this why design this structure also for the purpose STLC purpose. Okay, so the so-called RCS radar cross section is this the RCS. Okay, radar cross section. Okay, for this monitor the speed of the car, right? Okay, this for satellite, maybe this for smart weapons. Okay, smart weapons. For enemy, then can shoot for friend, might shoot. Some maybe RFID technology also can be used for those modern smart weapons. Okay. So anyway, for IF communication, previously for military application, the cost is secondary. The performance is very important. Okay, very important. But now, actually for military application, for satellite, nowadays in Singapore, just now some students ever asked, okay, the industry for FM, right? Actually, for local students, there are more opportunities compared with foreigners. Okay, our defense industry need a lot of IFM, okay, with EM background. Okay, for instance, ST satellite, ST satcom, right? Even DSO, okay, right? Okay. So EM microwave play a very important role for those advanced applications. Now Singapore invests a lot for satellite, right? Okay. Initially, NTU launched a few small satellite. Last December, NUS finally also launched two satellite, right? Okay. Small one and another slight big one is a micro satellite. Now, one is I think my colleague were highly involved in the full satellite. Okay. One satellite is only a few kilograms. It's so-called cube satellite. Okay. So I guess also on our microwave too. We will still continue on that. Also, we can design those antennas by using very advanced manufacture technology. Also, we are working on that, the so-called 3D printing. Okay. 3D printing can be used to design those maybe co-design antenna and mechanical structure. Okay. Also, those transmission lines that are explained for those waveguide transmission lines also can be manufactured by using 3D printing, even the RFID antennas. Actually, we are discussing with industry to have some grant or money to support our research staff also for this new area. Okay, how to make full use of 3D printing technology. Okay, 3D printing. For the 3D printing area, the government has invested huge money. Okay, more than 100 million in dollars. This industry sector can be used for these different applications. Okay, right? Consumer electronics, definitely everyone now every day, almost every day, right? Are using the RF microwave technology for consumer electronics, smartphone, Wi-Fi, laptop. Okay, right? Here I emphasize the antenna solution, right? Okay. So actually, each smartphone, so these those older phones, right? Okay. Right? Nowadays, those smartphones are using the case, right? Using the case, the design the antenna. Those are the antenna output for older phones. Actually, in each antenna, a mobile phone, maybe there are multiple antennas for different functions. Okay, different functions. This is the so-called triple band, right? Including this quarter band, then LTE, then fifth generation, then maybe GPS. Also, right? GPS. Now, with the GPS, actually everyone is enjoying, right? back, or some other electron come back. Okay. For all these applications, either the wireless communication, RF technology. Okay. Another good news is also as mentioned previously, okay, Maxwell equation has not changed since the equations were invented, right? Okay, more than 140 years. Okay, it is good, right? Even maybe after a few years, if you switch to other industries, then you come back. All those theories are still there. You can still work on in this industry. However, for computer engineering, if you leave for maybe 1 or 2 years, then you cannot catch up, right? But for our industry, even for some maybe ladies, you could have a baby, then you rest for a few years, then you can still come back to catch up. Okay? The Maxwell equations will not change, at least in foreseen time, right? Okay? So that is good news for our RF engineer. All this will keep change slowly, not like computer engineering. Every maybe 2 years, everything could change a lot, right? Okay. So for this PC, also laptop, there are some antennas. There's some antenna there. Okay. For the car collision radar, just now we mentioned what frequency nowadays are being used. So from advanced car could have a few radars. This typically anti-collision, so called long distance field, long distance, only maybe up to 200 meters. Just now we mentioned the long distance is 1,000 kilometers. Here is 200 meters for this application. For new distance, this new distance will crash or side crash, okay, or blind spot. Typically cause new distance. This currently typically 24 gigahertz, one frequency band. Maybe for new distance, right? Another is 77 gigahertz or that frequency band. Sometimes 78 to 81. Currently is 77. Okay. People are also looking at 78 to 81, maybe for different applications for this car radar, or maybe autonomous car radar. Nowadays, for autonomous applications, light wave or LiDAR is being used. So, okay, for the car radar industries, people are also looking at light wave. The performance will depend on the weather. Okay, will depend on the weather. Okay, for instance, in the haze, okay? Not during the night, LiDAR or light wave. The approach may not be efficient. Okay? Not efficient, actually not efficient. Not good. Or not good during the night. Okay? Now in the industry, people are looking at how to make full use of microwave for autonomous Carolina. This is another very hot topic, very hot topic. Okay, actually this morning all our professors from the electrical engineering also ever talk about this topic. Okay, so in Singapore we have one company is DeFi. Who is from DeFi? In our class we don't have students from DeFi. Okay, it's a United States company which is working at Carolina. Okay, so here every slide actually represents when you go